Key information, right? With a question regarding the logistic curve or the logistic equation, like I said, in some sense you don't have to know a lot of the information about the curve, like these kind of terms, so to speak, right? But all of this always helps in giving information about what kind of numbers to expect and just a better understanding before you dive into it. Because as you're going to see, the operations are going to be similar, right? Remember, this whole thing is about solving differential equations, which means finding like what the p is going to be equal to, or finding particular things about points in time, right? So that's what we're going to be doing here. In this equation, in this question rather, you've got an equation, and Eva, what is that equation? The first one, yeah.
1 on.
Oh no, sorry. No, the one you were saying. Yeah, that's right. Yep.
0.0024.
Mm-hmm. Yep. Bracket 1000 minus p. Okay, cool. And then what else have we got going on here? We have well, like, what's the situation? We've got a farm. 250 fish, okay? And the differential equation which shows the modeling of this situation is this. And so, like I said, you don't necessarily have to break down the equation in its entirety before you start. But like I said, you can get a bit of understanding with what's going on here. Like, we've got a fish, which is, we've got a farm of fish, which we're like farming or whatever, right? And we want to grow that population. But obviously, that population is constrained by, like the size of the farm, or, I don't know if fish eat each other? I don't know. I don't know too much about agriculture. But yeah, someone else can inform me. But like, this value is interesting because remember I said like this is in a model of this equation. And so we already have some indication that there's going to be a limit to this, right? The carrying capacity. Or most likely be 1,000, yeah, if I've written this out right. The other thing to consider is that they have these equations in different forms. And the first thing asks you to show that, Harry, did you get that equation down? This one here?
Yeah.
Yeah, actually, because I need it. Yeah. What is it? 0.0024.
Yeah.
What? P, yeah. And then, yep.
1,000.
Yep.
Minus
P is equal to what?
Is equal to 512.
Yep.
Bracket 100 P.
Mm-hmm.
Plus 1 over 1,000 minus P.
Yeah, okay, so pretty like long thing to start, right? But most applications of differential equations, which are logistic curves, will start off in this way. And let me explain why. Because, remember, the whole goal is to get from this to this. How do we actually do that? Finding the integral, right. And typically, it's easier to integrate something that's separated by addition. Like, it's easier to integrate something like this, 5x squared plus sine x. It's easier to integrate something like that when they're separated by addition than it is to integrate something like this, 5x squared times sine x, right? So these obviously aren't the same, right? But I'm saying that, can you see that integrating something that's separated by addition or subtraction is easier because you can do these separately, right? Whereas when it's like a product like this, you have to kind of think about some other rules and things like that, right? So this is an example of that. See, this is a product, right? There's something multiplied together in the denominator. And this is an addition problem, right? There's two things here which you can integrate. Just out of curiosity, if I was going to, like I haven't done this yet, but if I was going to integrate this, can anyone see what these would be? Logs, they'd be logs, right? This is actually an extension to skill called partial fractions, right? But they're not asking you to do this off using that technique. They'll always give you this and you'll just have to show it. How do you show it? Well, typically what you do is you start from one side and go to the other. And remember, the side you want to start from is a side where you can do more things. I'm looking at this, I'm like, okay, this is already grouped together. It's kind of hard to split that up. But if I've got this is separate, I can put it together. And if I can start from this side and end up with this side, then I can show that they're the same. But have in the back of your mind that you're going to want to integrate with this side because it's easier to do, right? So let's start off with the right-hand side. Okay. And when I said we can put them together, what am I talking about here? Well, we can put them under a common denominator, right? Yeah, so you can do your tricks there. So let's go ahead and do that. So we've got this multiplied by that, so 1 times 1,000 minus p on p plus, and then we multiply this denominator by that as well. So p on there we go. So that's a common denominator now. Let's group some like terms. When you put these under a common denominator, it does turn out to be quite nice, because you're going to get 1,000 minus p plus p all over this. And we can see that these are just going to go away. And I've got this right now. So I've got 5 on 12 outside this whole thing. So what I might do is I might expand it out so I don't have this constant. Because again, think about like what you're sort of heading towards, right? Don't just kind of do operations, right? Think about, okay, in my thing that I'm trying to end up with, I'm trying to end up with the left-hand side. I don't have this 5 on 12 thing. That's not there, okay? So I obviously don't want that in my final thing. I'm going to try and get rid of it and expand it out. So I've got 5,000 on 12p outside of 1,000 minus p, all right? Now, at this point, it's kind of like, I've got this. It doesn't seem like I can really do much more in terms of like algebraic operations, because other things we can do, we can expand. But remember, think about what we're trying to get to. I'm trying to get to something like this. It's what they want you to think. Okay, so what else can we do?
Get that fraction.
What fraction?
Get the, do it.
Do you want to elaborate on that a bit more? Because right now, we've got this random 5,000 on 12, and like there's no 5 or 12 even in that final thing, right? Here's something that I like to do. I like to think about what's different between this fraction and this fraction. What's different about it? We can see there are some parts that are the same. The 1,000 minus p is there. That's good. There's also just a single variable p there, which is good. But something's a little bit different about it.
One's for one on top.
Yeah, that's actually a very key important difference, right? One has a numerator of 1, one has a numerator of 5,000. So how does that 5,000 just kind of go away? Remember, you can't change the expression at all, but what you can think about is, can I rewrite this in the same way, but not change the value?
It is legal to like get it and like flip it and put it on the bottom.
What do you think?
I think so.
Yeah, okay, so this is where you need to use some algebraic tricks, right? So the algebraic trick is to think about, okay, if I just want to remove the 5,000 off the top, I can't really just do that without doing something else, right? So Matt's realized that if you write something like this, if you write 1 over, what did you write? 12 over 5,000 on the denominator?
Yeah.
Yeah, so you had like what, 12 over 5,000 p, like that. But that's actually going to be the same thing.
So if you multiply by a big number, or you divide by a little number.
And another way you can think about this as being the same is, remember how we can do operations to the top and bottom of a fraction, right? What operation do we want to do to this to kind of remove the 5,000 in terms of division? Well, we divide by 5,000, right? So you could divide this numerator by 5,000. But if you say, I don't want to change that, then I have to divide the denominator by 5,000 as well. I shouldn't have that there. That's misleading, right? So can you see like that will end up being the same thing, right? And so at the end, this, if you put into your calculator, does end up being the value that we want, and it does end up being the right-hand side, okay? So just to kind of summarize that whole thing, basically, questions will typically start of this type will typically get you started on a question like this, showing that one thing equals to another, and then you'll have to do your algebraic manipulation to do that. And ultimately, the goal is so that we can use this to answer the question. Right, can you get part B up, because we're going to need part B in a moment. Any questions about this one so far?